We're going to apply trigonometry to special triangles. So we're going to learn the theorems behind these special triangles and the relationships between the sides and hypotenuse of a 40-45 degree angle and a 30-60 angle right triangles. We're also going to establish the trig ratios for the 40-45 and the 30-60, and then we're also going to find missing sides or angles of 45, 30-60. So the first special triangle that we have is a 45-45 right triangle. So 45-45 means that the acute angles are the same, which means that the legs also have to be the same. So if this is x, if this is a measure of x, then the other leg also has to be a measure of x because they are the same. Now to find the hypotenuse, or to prove the hypotenuse, we can use Pythagorean theorem, which says x squared plus x squared equals c squared. Well, x squared plus x squared is 2x squared. So now we have 2x squared is equal to c squared. Now what we're going to do is we are going to square root both sides. So when we square root both sides, we end up with c by itself, but then we also end up with x square root of 2. So c is going to be x square root of 2. So no matter what our side is, we're going to know that the other leg is the same, and then our hypotenuse is just going to put the length of that side next to a square root of 2, and that will always be our answer. For any time you have a 45-45 special triangle. Okay, so the theorem that we just proved says that if the length of a leg of an isosceles right triangle, which is 45-45, is x, then the length of the hypotenuse is x square root of 2. Okay, sorry, let's go back. Since we know that one side is 4, that means that the other side has to be 4. So side A has to be 4. And if we want to figure out C, we can use our theorem, which says that if x is 4, then the hypotenuse is x square root of 2. So that means that our hypotenuse is 4 square roots of 2. Now when we do our 45 degree angle, we can either pick A or B. Both are 45 degrees. So let's just do A. So sine of A is opposite over hypotenuse. So we get 4 over 4 square roots of 2. The 4's cancel out, leaving us 1 over the square root of 2. And then we're going to rationalize by multiplying both the numerator and the denominator by the square root of 2. So 1 times the square root of 2 is the square root of 2. And then the square root of 2 times the square root of 2 is just 2, giving us our final answer of the square root of 2 over 2 for the sine of A. Now let's do cosine of A. Now cosine of A is going to be adjacent over hypotenuse. However, we know that the adjacent is 4, just like the opposite was. So we end up getting the same answer, the square root of 2 over 2, which makes sense because the opposite and adjacent are the same number. Now when we do tangent of A, it's opposite over adjacent, which is 4 over 4, which is equal to 1. Now let's do the second special right triangle. This is going to be a 30-60 triangle, and this is what makes this triangle special. If we were to make a reflection of it, then we end up with the 60-60-60 triangle, which means that our hypotenuse is going to be 2x because each side has to be the same. And if this is x, that means this is x. So the whole length is 2x. And this makes up a whole length, which means this is 2x. So x, 2x. Now we just need to figure out what is this length. We can use our Pythagorean theorem to figure out that length. So we have x squared plus b squared is equal to 2x squared. Go ahead and take care of that exponent. So we get x squared plus b squared equals 4x squared. Now we're going to solve for b, so we're going to subtract x squared from both sides. So b squared is equal to 3x squared. Now we're going to square root both sides, which gives us b equals x times the square root of 3. So that means that side is x square roots of 3. So if we know one side of our triangle, the shorter side, then all we have to do is times that by the square root of 3 to know the long side, and then we have to multiply it by 2 to figure out the hypotenuse. So the theorem that we just proved says that the length of the leg opposite of the 30-degree angle of a 30-60 right triangle is x. Then the length of the leg opposite is x square roots of 3. And the length of the hypotenuse is 2x. So let's do a practice problem. We're going to find the side lengths and the trig ratios for the acute angles of the 30-60 right triangle. So if we know this is 10, then we know that our hypotenuse, which is side z, is 2x. So if x is 10, that means 2x is 20. So we know our hypotenuse is 20. And remember, this side here, our theorem said that it's going to be x square roots of 3. So since our x is 10, that means we have 10 square roots of 3. Now we have to find all of our trig ratios. And we actually have to find 6. We had to find 3 for the 30 degrees and then 3 for the 60 degrees. The 30 degrees is angle x. So sine of x is 10 over 20 since it's opposite over hypotenuse, which gives us 1/2. Now cosine is adjacent over hypotenuse, so that's 10 square roots of 3 over 20. And when we reduce that, we get the square root of 3 over 2. Now tangent of x is going to be 10 over 10 square roots of 3. So when we reduce, we get 1 over the square root of 3, but we have to rationalize by multiplying the numerator and the denominator by the square root of 3. So 1 times the square root of 3 is the square root of 3, and then the square root of 3 times the square root of 3 is just 3, giving us the final answer of the square root of 3 over 3 for tangent of x. Now let's do our 60-degree angle, which is angle y. So our sine, which is opposite over hypotenuse, remember opposite of y is 10 square roots of 3, over our hypotenuse, which is 20. So when we reduce that, we get the square root of 3 over 2. Now we can do cosine of angle y, so 10 over 20, which is 1/2. Then we can do tangent, so that's 10 square roots of 3 over 10. And then when we reduce that, we simply get the square root of 3. So now we have seen our special triangles. And I want you to know it does not matter what you choose for x. Your trig ratios will always be the same. Always, always, always. Your sine of 30 degrees will always be 1/2. Your cosine of 30 degrees will always be the square root of 3 over 2. And your tangent of 30 degrees will always be the square root of 3 over 3. It does not matter what you pick for x. Your tangent value or your trig values will always be the same for your 30-60 triangle and also your 45-45 triangle. So given the following measure of sides, determine if the triangle is 45-45, 30-60, or neither. So we're given 5, the square root of 5, and the square root of 30. So that doesn't fit any of our patterns, so we have neither. Let's do 6, 2 square roots of 3, and 4 square roots of 3. All right, this is the 30-60, and the reason why is because you can start with 2 square roots of 3, and if you multiply by 2, if 2 square roots of 3 is your x, then 2x is 4 square roots of 3. And then x times the square root of 3 would be 2 square roots of 3 times the square root of 3, which is 2 times 3, which is 6. So this pattern is the 30-60 triangle. Now we have 4 square roots of 2. This one's easy. This is the 45-45 because we have x, and then x square root of 2. Last one, 9, 12, and 15. And this is neither pattern. All right, go ahead and try 2 through 6 even.